Hi guys, my name is Mike and I built another percussion robot, but in contrast to all of the other percussion robots that I've built, this one isn't really designed to play music as such. It's designed to record sample libraries. And what that means is that it doesn't necessarily need to be able to play fast and move around the instrument. It just needs to be able to play individual strokes. It needs to be able to play those strokes with a variety of different strengths. It needs to do that repeatably, and it needs to be absolutely quiet so that it can't be heard in the recording. And right off the bat, I want to say that this video is not really sponsored, but I did this in collaboration with a company called SoundIron, who sells sample libraries, and they plan on using this robot to do that. But the only reason I chose to work on this project is because I genuinely think that it's a cool project, and I think that SoundIron is doing a lot of interesting stuff. So yeah, feel free to go check them out if you want to. So I was talking to Mike over at SoundIron. I don't know why everybody's name is Mike all of a sudden. But SoundIron Mike already worked out that this kind of thing is pretty good for striking drums. It's kind of a mass on a rubber band. And this is pretty flexible in the sense that you can put different objects or different materials on a rubber band like this to produce different kinds of sounds. And so what I need to do is build some kind of mechanism that can come down and pick this thing up and then release it, thereby striking the instrument. And we reasoned that an electromagnet might be a good way of doing this. And this electromagnet is kind of interesting because it has a permanent magnet inside of it. So even without any power to it, it's already magnetic. And then if you put current through it in one direction, that kind of doubles the strength of the magnet, so it becomes really strong. And then if you put current through it in the other direction, that kind of cancels out the permanent magnet, so it just becomes completely unmagnetic. So then if we put a little piece of metal on top of this striker, we should be able to bring the magnet down and use that to kind of pick the striker up and then release it. And importantly, the release then ought to be totally silent. So then I just need some way of moving the magnet up and down. And if you've seen some of my other recent videos, you might have noticed that I've been playing around a lot with these linear servo motors. And these basically have a rod that extends out of them. And you can set this rod to any position and then it will hold there with a pretty good amount of force. So I mounted the electromagnet on the end of the rod in one of these linear servo motors. And then I built a circuit to control everything. And the circuit is basically just a teensy microcontroller with whatever other peripheral devices are required to make the motors work. And so this is plugged into my computer with a USB cable. And when I turn this on, it shows up as a MIDI device in my operating system. So then I can open up my digital audio workstation and I can route the output of a MIDI track to this circuit. And so I've programmed this circuit in such a way that if I play the note middle C, this motor will extend down, turn the magnet on, retract, pause for a second to wait for a complete silence, and then release the magnet. And then so I've also programmed this so that the MIDI velocity controls how high the motor retracts before it releases the magnet. So you should be able to get different striking strengths that way. And so then to get this working with this striker, I laser cut this little plywood box, and that kind of holds the motor in place. And then I managed to cram all of the circuitry inside of there. And then SoundIron Mike sent me this actually really nice stand that holds the striker. And so this box that I built just bolts on top of that stand. And so then this is what the whole thing looks like. And then I can plug that in. and then I need to adjust the height of this thing. So what I can do is move the motor all the way down, turn the electromagnet completely off, and then I can put this thing exactly where I want it and lock it into place. And so when Sound Iron Mike sent me this striker, he put this steel screw into this wooden ball. So let's see if we can pick that up with the electromagnet. So we can pick it up a little. Let's see if we can pick it up a little further. Oh, that failed. So it's supposed to pick it up and hold it for a second, but it looks like it kind of dropped off. Yeah, so it's just falling off. I think that metal screw just isn't enough metal for the magnet to hold onto. So I glued this big chunk of steel onto the other striker. So let's see if we can pick that up. So that one we can pick up a lot higher, but still if we try to pick it up any higher than that, it'll fall off. Yeah, so you can't really pick it up that high. And I think part of the reason is that this metal chunk has a big hole in the middle of it, so the magnet won't attach to it very squarely. So I drilled a little bit bigger hole in this wooden ball, and then I put a steel worm screw in there and screwed the metal chunk onto that. So that at least fills this hole with some metal. And so now when I do that again, you can see the magnet picks this up a little more squarely. It's still not getting quite in the middle of that metal chunk, but it's a little bit better. And now I can pick this up all the way to the top of the range of the motor, and it'll hold onto it there, no problem. So one thing you might have noticed is that whenever the magnet releases the striker then rotates out of the way, so this metal chunk kind of ends up on the side, and I have to manually reset that for the next stroke, and that's kind of annoying. So I put some super glue on there to try to hold it in place, and that did work, but it was also a complete mess, and after a couple of days it kind of disintegrated. So then I made these clippy things that glue onto the striker. And that holds this in place much better. Okay, the other thing you might have noticed is that this isn't that quiet. When it releases, it makes this kind of loud rattling noise. And this turns out to be why. So if I just hold this in my hand, you can hear it's a lot quieter. So I ended up just getting rid of the boom, and that kind of solved it. Yeah, so let's try striking an actual instrument with this. So I'll strike this glockenspiel at a variety of different velocities. Yeah, so that sounds pretty good. And I realized afterwards that if I take the audio from that and put it into Reaper, Reaper will tell me the peak amplitude of each one of those strokes. So yeah, I just imported the audio into Reaper, and I'm going to press play, and then I'm looking at the VU meter down on the bottom left of this screen there. Yeah, so that was one stroke, and this is telling me that that peaked out at about negative 18.8 decibels. And so I plotted each one of those strokes. So this is peak amplitude is a function of MIDI velocity. And you can see it's pretty linear, at least below MIDI velocity 75 or so. So greater MIDI velocity results in higher amplitude, so that's good. And then above MIDI velocity 75, I think the recording just clipped. You can't record above 0 decibels, so we don't really know how loud the loudest sounds were. But this at least demonstrates that that is working. So the other thing is that this motor is actually capable of measuring how much force is being applied to it. So as it's lifting up this striker, it's kind of applying more and more force to lift that striker higher. And so I built this web interface where you can use this kind of slider to specify how much force you want. And then the motor will lift the striker higher and higher and higher until it reaches the desired force, and then it'll release the magnet. And then this dial here kind of plots in real time how much force is being applied to the motor. So let's try striking the glockenspiel again with different amounts of force. Yeah, so that seems like it worked pretty well. And so I plotted this again. And so again, this looks pretty linear, at least up until the point that the recording clipped. So this is definitely working the way I intend it to be. And what I think is happening is that force probably corresponds directly to height, and height corresponds directly to loudness, and we need a little bit more data to really be certain about that, but yeah, that looks like it's probably what's happening here. The benefit of using force mode is that if the rubber band becomes weaker over time, then this force mode will kind of compensate for that and still give you the loudness you want, so it's more repeatable in that sense. So the only thing that I really wasn't able to solve is that it seems like often the striker comes down and bounces off of the surface multiple times. And so I recorded some higher speed footage at 240 frames a second so that you can see that really clearly. So I'll play that for you now. And so I'm not quite sure what to do about that. I'm kind of hoping that just very carefully positioning the robot relative to the instrument will help mitigate that. But if any of you have any suggestions about what to do about this, please comment below. I'd be interested to hear what you have to say. Anyway, that brings me to my final point, which is that it really does help me when you guys leave comments, subscribe, like, share on social media. All that kind of stuff really does help me. I know that some of you already do that, and I notice that, and I appreciate it. So thank you for that. Anyway, so I think that's all I have to say about that for now. So thanks for watching, and I'll see you next time. Bye!